This is a Blender Python tutorial where we create a script to brainstorm different reverse key lighting setups for a given scene. Hey, I'm Victor Stepanov. I'll be guiding you through this Blender Python tutorial. Recently, I watched Gleb Alexandrov's tutorial on the reverse key lighting technique in Blender. I learned a lot from that video, and that video got me thinking, how can I quickly find the optimal and interesting reverse key lighting setup for a given scene? I remember a while back watching Andrew Price's tutorial on creating a cabin in the woods, where Andrew used some keyframe modifiers and noise to brainstorm camera and lighting positions for his scene. But I wanted a bit more control, so I decided to see how far I can get with a Python script. To follow along, you can use your own scene or head on over to polyhaven.com and grab a model and a texture from there. I'll be using the following. I decided to use this texture for the floor. Thank you, Rob, for creating this and putting this out there. And I'll be using this model of the barrel. I'll be using this broken model right here. Thank you, James, for creating this and putting this out there. I'll provide a link in the description to that model and this texture. I've created the scene. I just moved one of those models into my scene, and I created a plane and applied this texture. Also, I scaled the texture so it looks right for this given scene. So I don't have anything except the plane and this barrel model in the scene. The camera, the light, is going to be something that the Python script is going to be adding. If you're going to be using your own scene, make sure to back it up. So make sure to create a copy and work on the copy with the script that we'll be creating, so it doesn't ruin your work in any way and you have a backup. To quickly start iterating on our script, I have provided some starter code in the description under Start Code. Open that link in your favorite browser, hit Raw, select the code and copy it. Let's head on over to Blender and let's open the scripting workspace. So we're going to scroll right here and open the scripting workspace like so. Hit New to create a new script and then paste in the code you just copied. Let's make sure to save this script right away. So I'm going to go into text and then save. And I've navigated to a folder that I like, and I'm going to name it to.py. And .py is the extension for Python scripts, and let's save that. Let's quickly take a look at what this script does. I'm going to go way to the top of this script, and we're importing some functionality. I'll be covering where exactly we're using each one of these modules. The main one that we usually use in Blender Python scripts is BPY, so that's here. Next we have this region of helper code that's why we actually copied our script, right? It's going to help us do all of this quickly. So let's just go over what we're doing here. We're getting a path to the temp folder in the home folder. Next, we're getting the path for the metadata. We're going to be using that towards the end of this video. We have a parenting function to parent objects to each other. And we're creating an empty, a camera, and a light. And we're setting the name, the location, and so on. So all these properties get automatically set. The camera is tracking the empty, right, that we've provided. And we have an area light that is also configured. And all this is wrapped up in this create like light rig function that creates the empty, the camera, and the light, and returns these three objects to wherever we're calling this from. Also, I set up the scene to each time when we run the script, we would remove all these objects. And note, it will only remove the objects that have the special tag that we're adding. So notice that when we're naming each one of these objects, so the area light, we're using this tag right here. I've defined it up here. It's just a piece of text that we're using in our formatting for the camera name, for the area light name, and for the empty, right? So we're just based on that fact, we're filtering with this line, we're filtering all the objects in the current scene and only removing those ones that we've added. So this shouldn't remove anything from the scene, except those lights. Of course, except for some reason you've named one of your objects in the scene to contain brainstorm, so probably would delete that, but I'm gonna take a wild guess that you are not naming your objects with brainstorm in the name. All right, so that's gonna happen. We have the scene set up. We clean the scene, right? We create that camera and light rig. We set the camera to be active, the active camera for the scene, and then we set up the scene resolution. I'll be using cycles today, and also setting the resolution of the scene. So I don't want to run, since we're brainstorming, I want to use only half the resolution. So I don't want to get the full resolution, and I'm just setting the samples to 50 or even lower, right? Just to make this iteration faster. That was a quick overview of our helper code that we'll be using, and it's time to run the script. Let me zoom in to the center of the scene. And I'm gonna hit Z on the keyboard and then hit rendered. And right now there is no lights and it's pretty dark. So now let's run our script. I'm gonna hit the run button right here. And this added the camera. And let's actually go to material preview so you can see it a bit better. So there's the camera, there's the empty, there's the light. I'm gonna hit Control Space to get a better view. And so the camera is tracking this empty right here in the middle, right? So it's tracking, as you can see, with the camera, and it's still looking into the center of the scene. Go back, and each time we run our script, this is gonna just remove this camera and light setup and add a new one instead. All right, let's go back to rendered. You can see that the light is really dim, and let's update that right away. And let's go into the settings of the light, and let's set this to, let's say 1500. And okay, that's already giving us something. Set this back, and let's copy the code for creating for setting that light power. And I'm gonna just paste that code in right there. And we're using the area light object. So this is referencing our area light that we're creating right here. And I can replace it like so. So we're accessing the data and the energy and then setting that right there. So we can actually, let me show you, I'll just remove this from the scene. And as soon as we run the script, it's gonna add the light with that power. Let's run that and look at that. Right there, we already have something going on. Let's render the scene and see how it looks. Okay, this is the result. So you can see that it's already creating something with a script. All right, let's start by organizing our code right away so it's nice and clean as we go. And I'm gonna create a new function here and name it apply scene configuration, like so. So apply scene configuration, and I'm passing in the area light object and applying that value right here. So we're setting that right there. Again, I'm gonna paste that in. Let's change this to 2500, and let's rerun the script. And notice as I rerun the script, it's gonna get a bit brighter. And you can see it's now a bit brighter. This is still working. All right, we're going to be organizing all the scene configuration setup right here, so we can later on save this out. Next, let's create a separate function for rendering out the scene and saving it into a file. So pressing this render image button for us and then saving it into file. I'm going to create a new function right here. Here it is, and let's render scene. And let's go over each one of these lines. So first we're getting the output folder path. Remember, we're defining it up here. So let's go up, so get output folder path. So it's in the home folder, and in the home folder, there's a temp folder, and that's what we're gonna be using for the rendered images. So we're getting that path, and then we're getting a timestamp. So I'm using date and time. So remember, we're at the very top, we're importing some functionality, and here it is. We're importing date and time to work with times and days in Python. and we're getting a timestamp with the format hour, minute, second. So it'll create a piece of text, a string, that will be the current. So now it gets the current time right now and creates a piece of string out of that. And now this is timestamp, and we can use that for the name of our image. And here's the name of their image. We're using F for formatting, and we can, once we use F for formatting strings, we can use these curly braces to add variables into the piece of text. So remember, this is defined above. It was like brainstorming, and we're using the timestamp that we created right here. So that's the name of the image. And then we're setting the file path that we're using to render out the image, converting. So we're creating a path here. This is not a piece of text. This is a path object. It's very important because you can use this right here to start creating a path and maybe check if something exists on disk or not. So it's really useful. And we're finally doing another string format here. We're using the name we created right there. PNG image is what we're going to be rendering. And we're creating this new path and applying this as the final path. And then finally, we're hitting that render image button. So that is exactly this. So right still. And now we need to call this function, since we've defined it right here. After we've set up our scene, we've applied the scene configuration, and then we're going to render out the scene. So let's go and take a look at the home folder. So the home folder and the temp folder that's in that home folder. So here is my home folder and the temp folder inside of that. And remember, I saved my script right here. So this is the script that we're working on. It's right here. Then that's the scene. And we're going to get the image generated right here as soon as I run the script. So let's do that. And Blender is going to hang for a second because we're rendering out the scene. And look at that, we have this image right there. And that looks similar to the image that we got when we're doing this by hand. And take a look at the name of the file. So it's the brainstorm tag that we're using and the time. All right, thinking a bit ahead, I want to have the ability to restore the parameters that I like. So for example, I set this script going, it's generating different scene combinations, scene setup combinations. And if I select a given image, I want to have the ability to get the same exact scene setup. And to do that, I need to have some way of storing the data that I used for this for a given scene configuration. And of course, you can say that, I can add maybe the energy value of the light right here. So like, for example, we would encode in the name of the image, like, I don't know, put like E whatever for the energy, and then extract the data from the name. But that doesn't really look like it's going to be scaling well, because if we add a ton of other information there, the name of the image is going to be like huge. It's going to be a big pain in the butt to actually extract the information. And to make our lives easier, I think I'm going to just create a JSON file, like a metadata JSON file that will contain all the parameters that we're going to be setting for a given scene. So let's do that now. The first thing I want to create is a dictionary that will contain the scene configuration. And I'm going to go right here and create the dictionary that will contain our parameters. So here is the dictionary, and we have the light power, and then we're applying that value, whatever we want to it. And so I'm using a dictionary because it maps perfectly to JSON files, and we're going to be saving this dictionary into a JSON file. Let's pass in that dictionary that we've created into the apply scene configuration that we defined up here. I'm going to add the scene configuration parameter here, and instead of using this, I'm going to use the scene configuration and then access this key right here, and this way passing along this value, right? So that is set. Next, we need to think about how will we identify the metadata, or just how are we going to name the file. And the first thing that comes to mind is to use the image name that we've created. So if we like a given image, and I want to say like I like this image from 1204, right? I can just copy that name, and by using that name, I can look up the metadata that's associated with this file. So we're not going to be reinventing the wheel or anything, and just going to use the image name. So in the render scene function, I'm going to return the image name. So this will return the image name. And now with that information, I want to create a separate function that's going to be saving out the scene configuration into a JSON file. So let's go up here and create that file, create that function. Okay, here is the function. So save scene configuration. We're passing in the image name, and we're passing in the scene configuration that we want to save. We are getting the metadata folder path. So let's go into the helper section and look what that does. So the metadata folder path is right here, and we're getting the temp folder, the output folder path. So this is the thing right here. So we're getting the temp folder, and then in the temp folder, we're creating a metadata folder to nicely organize our metadata files. And then remember how I said that this is a path object, and we can use this really cool feature and test if this path object exists. We're testing if the metadata folder exists. So if it doesn't exist, so then we're going to create that folder. So this way we'll have something to save our metadata into, and then we're returning the path. So that's kind of the short story of what is happening there. So so we got that file path there. Then we're creating the JSON file with the image name. Remember, we're using the image name as the reference to getting the metadata. And then we're opening up that file for writing. Here's the reference to the open file. We're dumping, so we're using JSON. Remember, at the very top, we imported JSON. So to work with JSON files, Python needs to be extended, and we're extending it with the JSON module. So let's go back again, and we're using the dump S. So S is for string, so text. We're dumping the dictionary, the data that's contained in the dictionary, into a string, and using indentation, so it'll be nicely formatted, like for spaces. So we got the text right here, and then using the file object that we've created and opened right here, we're writing out the text into that JSON file. Okay, so let's call this right after we render. And that looks all right. Let's go ahead and run our script, and we should get a metadata folder, and inside of that metadata folder, we're gonna get a JSON file defining the scene configuration that we have right here. So let's go ahead and run that. And going and looking into the temp folder, we have our next image, and now we have a metadata folder. And let's take a look closer at what it contains. Okay, so here I've opened that JSON file in Visual Studio Code, and you can see that we've saved that metadata into this JSON file. Awesome. Now we're ready to create multiple scene configurations and loop through them, apply them, and render them out. I'm going to create a separate new function up here that's going to return a list of scene configurations. Okay, here is the function, so get scene configurations, and we're creating a list right here with square brackets, and inside of that list are dictionaries, and we have these 3 dictionaries which have different light power settings, and we're going to use that right down here and apply them and render them out. So again, we're getting the scene configurations here, and then we're looping through each one of those scene configurations we've defined, using this variable to host each one of those scene configurations, and applying, rendering, saving the metadata, and doing that for all the scene configurations we have. Let's go ahead and run our script. Again, when you're running these scripts, Blender is going to be hanging for just a bit while it renders out each one of those frames. And let's take a look at the result. We can take a look right away in the metadata folder. We've created these 3 new pieces of metadata, and then let's check out the frames that we've created here. And you can see that there's different light settings for each one of these 3 frames. Exactly that we can see that this script is already generating something interesting. Okay, let's go back. Now I want to capture the scene from different sides. And to do that, I'm going to rotate the empty that is in the center of the scene, and the camera and the light are parented to the empty, so we just need to rotate the empty about the Z-axis to get different angles for the whole reverse key lighting setup. I'm going to go right here above the for loop and define 2 variables, one for tracking what step we want to use for each rotation and tracking the current rotation of the empty. So with this, I'm tracking the rotation step. I'm using 90 here just to make it quick for this tutorial. You can set it to whatever value you want, from 1 degrees to 10 degrees to 30, whatever. And then we need to track the current rotation to save that into our metadata. So let's create the for loop, or the while loop. I'm going to use a while loop here, and I'm just going to make sure that we do a 360 rotation and repeat this code for each one of those steps when we rotate about the Z-axis. Also need to update this value right here. So with each iteration, we're going to be updating the current empty rotation about the Z with the step that we defined here. And also we need to update the scene configuration dictionary with the value of the current rotation, like so. We're adding a new entry with a key empty Z rotation and using the current empty Z rotation value. And now we need to pass the empty object into the apply scene configuration, like so. And we need to not forget to update it here. So I'm in the scene apply scene configuration where we're applying all these settings that we want to apply for a given scene configuration. And I'm using the reference to the empty object and the Euler rotation, in particular the Z-axis. And I'm using the thing that we are setting right here. So this right here, the current rotation, I'm using that. So remember, this is in degrees, and Blender requires us to provide angles in radians. So I'm using the math function that, you guessed it, we imported right here, extending Python's functionality, right, with the math module. So we can convert the degrees into radians. So after this is executed, it's going to be radians, and we apply the rotation right here. All right. Okay, I think this should just work, and I'm going to go ahead and run the script. Okay, the script finished running, and let's check out the results. I'm going to go into my temp folder and check out the results. Let's click on this. And you can see that we're rotating the barrel, or the rig, and we have these different lighting setups, right? Okay, this is starting to take shape. And actually, before I forget, let's check out the metadata as well. And here we're looking at the metadata for one of the images, and we have the power set, and we have the empty rotation set to 270. All right. Next, I want to change the angle of the camera on each iteration. So let's press Control Space to get a closer view. I'm going to select the camera, and actually I'm going to hit 0 on the numpad to get the camera's perspective. And if you notice, if I change the Z on the camera, the Z location on the camera, you can change the angle. So this is what I want to do next, is I want to just update this for each one of the rotations of the empty. I want to have a number of positions of this camera. So let's do that next. And to do that, I need to create 3 new variables right here. I'm going to be tracking, again, the current value. I'm going to be tracking the starting value because we want to reset the location of the camera each time we make a turn with the empty. I don't want it to continue to add and have weird angles, right? So I want to reset it each time, and I want to define the number of steps that I want to take. So here they are, the starting value, the step that we're going to take, and how many steps we want to take. And I want to reset this value each time. So I'm gonna I'll create a new variable right here. I could define it up here, but I'll just put it here. So each time we do a single rotation about the z-axis with the empty, I want to start from the start location of the camera. And let's update this. And we actually want to create another for loop right here that's going to be updating the camera location. And I'm using this for loop and using this count right there. And I need to update the current location, right? Notice that I'm subtracting the location. Instead of it going up, it's going to go down and create a nice new angle. So let's review. We have these 4 new variables: the start, the step, the count, the number of times we want to do this, the current value, and we have to reset it each time we make a turn about the z-axis with the empty. We have the count right here, so how many times we want to update the location of the camera. We are saving the value of the z location of the camera into the scene config. I haven't updated this yet. We need to pass in the reference to the camera, and we'll do that in just a second. And for each one of these things, we're going to be updating the location after we're done going through all the scene configurations. So let's update this with the camera object. Go up. We're using the camera object reference and accessing the location property, in particular the Z location, and updating with the scene configuration that we've provided. All right, I think we're ready to run the script again. Let's do just that. Okay, the script finished rendering. Let's check out the results. And if we take a look, we have different lights, and you can see that there's a different angle each time we switch the light. This is great. And let's actually check out the metadata as well. And not only we have the light, the empty rotation, and now the camera Z location as well. Okay, so we're getting this metadata so we can retrieve it and apply it to our scene. Now we need to work on the code that will extract the metadata and apply it to the scene. But first, if you're learning something new and enjoying this tutorial, make sure to hit the like button. This will help me understand to make more videos like this. Also, make sure to check out Gleb Alexandrov's new course on cinematic lighting in Blender. I already got my copy and I'm learning a ton. Let's say you like a particular image that was generated with this script. Now we need to somehow get the metadata and apply it to the scene so we can reproduce it. So we'll be using the image name, setting up the scene, getting the metadata, and applying it. Let's go back into our script and create a new function that will do that for us. Okay, here is the function. So it's load scene configuration. I'll be passing in the image name into that function. I've provided a doc string here for documentation purposes. And I'm setting up the scene, and notice I'm using the full resolution. So now we're kind of ready to render out final result, or maybe get a better glimpse at the full resolution of the image. It's going to be, again, creating the empty camera and area light, nothing new there. Now we'll need to define a separate function that's going to extract the scene configuration based on the image name. So I haven't defined this yet. I've just created a placeholder name here. And then we're gonna, if we actually find the scene configuration, this is going to be a key moment why we need to do this right here. But if we find the scene configuration, we can apply the scene configuration as we did when we're rendering out each one of those images. So let's go ahead and create this function that's going to extract the metadata up here. And here is that function. Again, we're providing the image name. We are providing a doc string. Remember how we got the metadata path? So we're doing that again. We're getting that metadata path. We're creating the file, the metadata file name using the image name we've provided. And also it's going to be important to use the image name without the .png part, right? Because we're going to be using it in the name of the JSON file. And again, we're double checking that this file actually exists on disk, because we don't want to be trying to load a file that doesn't exist. It's going to be an error and the script will fail. So we'll check that the file exists and we will open it for reading, and we'll read the text. So actually, you know what? I'm going to move this into text. It's going to be a bit more readable. So with this command, we're reading the contents of the JSON file, and then we're using the text that we just read. We're loading load s, so load string. We're using the JSON module and getting a dictionary based on whatever this text is. So this has to be valid JSON for this to work, and this will return a dictionary that we will return from this function. And if this file didn't exist, we're going to print out an error. I'm just using print. The best practice is usually to use the logging module, but that's a topic for another video. And I don't know what happened here. This should just return none. And this is exactly what we're testing here. Remember right here, when we extract the data, either it's going to give us the dictionary that we want, or it's going to get none. If this right here returns none, so this will be none, this will be false. It'll automatically be evaluated to false, and we won't apply anything to the scene because there's nothing to apply. But if there is some data to apply, we're just going to take the scene configuration and apply it to the objects that we created right here. Okay, now it's time to connect this all together into the main script. I'm going to go to the very bottom into our main function. Here we're rendering out the scene, but before this I want to have a way to toggle what we want to do with the script. Do we want to brainstorm, or do we want to load a particular configuration? Here's how the main function is going to look. This was the main function before, and now I've added this right here. We have a comment of what we want to do with this. So if I want to load a scene configuration, I need to set this to true. And if this is true, then we're going to use an image that we like, the name of it, and run the function that we just created. So let's go back and select an image. So I'm in my temp folder and I'm selecting this image name, just copying that and going back into the script and pasting in that name. This should update my script. This script should now update my scene to look exactly as it did for that particular render. Let's double check that everything's correct. Okay, I think this is gonna work. Just don't want to make sure that I didn't make any typos. Let's actually look closer at the scene. So as soon as I run this, this should load up that metadata for that particular image, and the scene should update and rotate, and the camera and the light in the way that is defined in the metadata. So let's run the script, and we have an error, and that is an error. Oh, yeah. So the problem here is I selected an image that had metadata that was created before I added the camera Z location. So you know what, I'm just going to regenerate all the images and run that again. So let me go here and I'll set this to 10. So now we're rotating the MT by 30 degrees, and we're going to be running through all this code right here. I'm going to go into my temp folder, and I'm going to delete all the images, so just in case I don't mess up, and I'll delete the metadata folder as well, so we know that we have valid metadata and valid images to go with that. So I'll be right back after this is finished running, so I'll start running it right now. And one thing I didn't tell you before starting the render, my render is already done, but you needed to reset this load scene config so we can start to regenerate the scene. And now let's go ahead and see the results. And here are all the images that were generated. Looks all interesting. And let's take, for example, this one. I'm going to copy the name, paste the name here. I'm going to set this to true. And now let's take a look. As soon as I run, it should update the scene with the parameters from that particular render. I'm going to run the script, and look at that. It did set something up. Let's take a closer look. And yeah, look, that looks pretty close to, not pretty close, that it looks exactly like that image. Great, now we can restore the scene from the metadata that we saved. And one final touch before we go, I want to add some extra parameters that in the scene configuration. So we're only setting the light power, but let's set some other things as well. Like so, I'm not only setting the light power, but the location, rotation, the scale of the light, and the camera focal length. Now, since I have this set, I need to update the apply scene configuration so we can apply these parameters. Like so, now we're applying the new parameters in the apply scene configuration. And when you start rendering and brainstorming different scene setups, you'll have extra parameters to play around with. I'll add a link to this final code in the description, so make sure to check out that if you weren't following along. Okay, what's next? Now you have this script, and you can continue to add different parameters to tweak for each of the scene configurations. Maybe you can add another light or replace the model in the scene. Dare I say, the possibilities are endless here. So if you repurpose the script, make sure to share what you did in the comments. If you have any questions about the script, you can also ask them in the comments. I'll be happy to answer. One thing that you might want to look into is, for example, the model is not in the center of the scene like I have right here. You can go and tweak the empty's location. So in the render scene configurations, you can update the scene location, the empty's location to something else, so you don't have to place your centerpiece in the middle of the scene, like so. And let me actually return from here. I don't want to start a new rendering session. I'll just want to run the script and show you that we can update the location of the empty and the camera rig. So make sure to set this to false, run that, and I'm gonna go into material preview to see. So you can see already that the camera and the light is not in the center of the scene. So let's see where it is. Okay, it's over there. See, it's moved from the center. So that's a way that you can update the location of the empty. Okay, make sure to remove that. And for more tutorials like this, make sure to subscribe, and thank you so much for watching.